All right, today we're going to talk about medians and altitudes. These are some more segments that occur in triangles. Yesterday we talked about perpendicular and angle bisectors, so now medians and altitudes, just giving us some idea of some different segments that happen in triangles and how that impacts the solving. So let's first talk about what is a median. And a median is a segment that goes from the vertex to the midpoint of the opposite side. Now, just because our diagram to the right there under where it says drawing is only showing one median, a triangle has three medians, one from each vertex. And we are going to see diagrams where more than one median is drawn in the figure. This is just a very basic figure off to the right to show us the idea of a median. And we know that this segment here in the drawing that it's a midpoint. And the way that we know it's a midpoint is because these two segments have been marked congruent, and if they're equal to each other, that point has to be in the middle of that segment. The point up here, the angle, this is called the vertex. So this is our vertex, which makes this actual segment our median. All right, another term we need to define is concurrent lines. Concurrent lines are three or more lines that meet at a single point. Three or more lines that meet at a single point. The diagram to the right just shows three lines meeting at point Z, so we would say that those are concurrent lines. And as you can see, the diagram for point of concurrency looks exactly like the diagram for concurrent lines, because point of concurrency is the point where the concurrent lines meet. So that point Z, where all those lines are meeting, that would be our point of concurrency. All right, and then the next term is the centroid. The centroid is the geometric center of the triangle. It is also the point where all three medians of a triangle intersect. So also the point where all three medians of a triangle intersect. And the centroid is 2/3 of the way from the vertex. So if we're looking at this diagram over here, and I'm only going to mark this on one of them just so the diagram doesn't get too filled up. So if we're looking at the segment, this segment here from the vertex to Q is worth 2/3 of the segment, which means the bottom segment is worth 1/3 because 2/3 plus 1/3 would equal 1 to give us a whole segment. So from the vertex to the centroid is 2/3 of the segment. From the centroid to the median is 1/3. And that's going to become important in a lot of the math we're going to do in just a moment, having to do with medians. And then the last term here, an altitude of a triangle, just like if you think of the word altitude in general, it's talking about the height. Usually we talk about planes flying at a certain altitude. We're talking about how high they're flying. So it is representing a height. It is a segment that goes from the vertex to a point on the opposite side and is perpendicular at that point. So again, in our drawing, that top of the angle there, that would be considered the vertex. And we know the right angle there is giving, we know that that is perpendicular. All right, now let's see how we're going to apply the math to go with this. So in each of these examples, it says each figure shows a triangle with one or more of its medians. And if it's showing us one or more of its medians, that means in this case, segment LR is congruent to segment RJ, segment LS is congruent to segment KS. And again, you notice for LR and RJ, I used one hash mark each. For LS and SK, I used 2 because those are 2 different sets of congruent parts in this triangle. So I can't use just one hash mark on all of them, because that would be saying that they were all equal to each other, and that is not the case. Now, they want us to find KR. KR is the entire segment here. They want us to find KR. We need to remember that there's a 2/3, 1/3 relationship here. From the vertex to that point where the medians meet, that is the 2/3, which means the bottom part is the 1/3. Now, sometimes I need to know both. Sometimes I'm only using one. They tell me that KP is 6. Well, again, I know that KP is equal to 2/3 of KR. KP is 2/3 of the entire segment, which is KR. So if I substitute in what I know that KP is 6. So 6 is 2/3 of segment KR. Now, I need to get rid of that fraction on the right, and how I undo a fraction, because if I divide, really I would divide by 2/3, but we know in dividing fractions we invert and multiply. So I'm going to invert and multiply both sides by 3/2. On the right hand side, that cancels out the fraction. So KR equals 3/2 times 6/1. Now, at this point, you could cross cancel if you want to, or you can just multiply through and simplify. It does not matter. If we multiply through, remember when multiplying fractions, we multiply the numerators together and the denominators together. So 3 times 6 is 18, 2 times 1 is 2, and then 18 divided by 2 equals 9. So if KP is 6, that means that entire segment KR would have to have a measure of 9. Number 2 says find LW if RW equals 12. Okay, so this is again where we need to pay attention to the information we're given. So they want us to find LW, which is the entire segment there. Again, we know that LW is broken up. LR is 2/3 of the segment and RW is 1/3 of the segment. This time they're telling me RW equals 12, so they're talking about the 1/3 of the segment. So RW is 1/3 of LW. So I do have to pay attention. What part of that median are they giving me? Are they giving me from the vertex to the centroid or the centroid to the median? So do I set it up with 1/3 or 2/3? So we know RW is 12, so if I substitute that, 12 equals 1/3 of LW. And again, if I divide by 1/3, that's really multiplying by 3/1. So I invert and multiply. So LW is 3/1 times 12/1. Well, 1 times 1 in the denominator isn't going to do anything for us, so we just do 3 times 12. So LW is 36. All right, more examples on the next page here. Find QY if IY is 9.3. Again, QY here, we're talking about this segment. The top of it is the 2/3, the bottom of it is the 1/3. And again, they're giving us IY, which is the 1/3 part, so we know that IY is 1/3 of the entire segment QY. So we know they tell us that IY is 9.3. So 9.3 is 1/3 of QY. So again, to undo 1/3, I multiply by 3/1, or just 3. So QY is 3 times 9.3. So what is QY? What is 3 times 9.3? 27.9. So again, you do have to pay attention. Am I dealing with the 1/3 part of the segment or the 2/3 if they're talking about the entire segment? We are going to get some examples where they don't give us the entire segment and we have to use another idea in solving here. So number 4 says find x. So now we're solving for x because they're giving us expressions. If dt is x plus 5 and di is 5x minus 3. So again, we're dealing with this segment here. dt would be the 2/3, ti would be the 1/3. So they're giving me dt and di. So dt is 2/3 of di. Which means dt x plus 5 is 2/3 of 5x minus 3. Now, because of this fraction, if you wanted to make it a little easier on yourself, we could actually start off by multiplying both sides by 3. On the right-hand side, it would cancel out that new denominator. On the right-hand side, we distribute and we would have 3x plus 15 equals, and then we would have to distribute the 2. So you would still have the 2 times 5x minus 3 left. And then distribute that 2 through, so we have 3x plus 15 equals 10x minus 6. If I subtract 15 from both sides, I have 3x equals 10x minus 21. Subtract 10x from both sides. Negative 7x equals negative 21. Divide by negative 7. We get x equals 3. All right, the next one, number 5. This one is different. They want us to solve for x. They're giving us WC and CS. So again, we have this segment here. WC would be the 2/3, so CS would be the 1/3. But in this case, they give us WC and CS. They do not give us the entire segment or aren't asking about the entire segment. So this one is going to solve a little bit differently if they're talking about both segments of the median. So if the top part of it is 2/3 and the bottom part of it is 1/3, that means that WC is twice as big as CS, the 2-to-1 ratio. They have the same denominator, so WC is twice as big. So it's going to take 2 of the CS to equal the WC. 2 of the bottom segments, so 2 of the 1/3 to equal the 2/3. So again, I know this one is a little bit different than what we've been dealing with. So this is going to take 2 of the 6x minus 4 divided by 5 to equal the 10x plus 12 divided by 5. So again, as I've been saying in this unit, it's all about evaluating the information that you've been given and understanding the relationships. And I know this one kind of took a left turn in a way because we haven't compared the two parts yet. So if I distribute that 2 there, that ends up giving me 12x minus 8 over 5 equals 10x plus 12 over 5. Now, luckily, they're both using the same denominator, so in order to clear that, I can multiply both sides by 5, and that's going to clear out those denominators. So really what I'm solving is 12x minus 8 equals 10x plus 12. So I'm going to add 8 to both sides. So 12x equals 10x plus 20. Subtract 10x from both sides. I get 2x equals 20. Divide both sides by 2, and x equals 10. I go back and check. That's what they asked for. They asked me to find x, so I don't have to go any further on that one. But again, that is a different relationship. I have to understand that the smaller segment, it takes 2 of the smaller segment to equal the bigger segment of the median. On the next one, it says find LC if LB is x plus 3 and LC is 2x minus 6. Again, at the top of the lesson or the examples, it did tell us that the figure shows a triangle with one or more of its medians. So even though they didn't put the markings, if AL is a median, that means that side has to go to a midpoint, which means that LB and LC have to have the same measure. So in this case, LC is equal to LB because of that median, which means that 2x minus 6 is equal to x plus 3. So if I add 6 to both sides, I get 2x equals x plus 9. Subtract x from both sides, and we get x equals 9. But that was not what we were asked to find. We were asked to find LC. And this is a problem I saw on the quiz where we did not necessarily always follow through and answer what was being asked for. So I know x is 9. I know that LC is the expression 2x minus 6. So now I'm going to substitute that 9 in. So that LC is 2 times 9 minus 6. LC is 18 minus 6. So LC equals 12. All right, then number 7, find GK if GK equals x and KC equals x minus 2. So again, we're talking about this segment here. GK is the 2/3. KC would be the 1/3. But again, this time they're talking about both parts. So again, this is where we have to know that 2 of the KCs would be needed to equal 1 of the GKs. Because of that 2/3, 1/3 relationship, I would have to double KC to equal GK. So 2 times the quantity x minus 2 equals x. I have to distribute that 2 to give me 2x minus 4 equals x. Add 4 to both sides. 2x equals x plus 4. Subtract x from both sides. And we get x equals 4. But again, they asked us to find GK, so make sure we are answering what is being asked for. So GK is just represented by x. So in this case, GK equals 4. But again, all of this is going to come down to analyzing the information that you're given, understanding the 2/3, 1/3 relationship, and knowing, am I applying it against the entire relationship, or am I comparing the two parts together, and how can I do that?